to chapters 3.1 to 3.4, pre-assessment or review. Let's look at the first section. It says determine whether the relation is a function. Remember the definition of a function. For every input, it has exactly one output. So meaning if we input, we see in this one, if we input 0, our output is going to be 4. No other place should we input 0 and not get 4. So we're looking at each of the inputs to see if they repeat, and they don't repeat anywhere. So this is a function because there are no repeating inputs with different outputs. So that's the easy way to look at it, is you just focus on the input. If you have two of the same inputs, make sure that the output is the same. So again, we're going to focus on the input first. So we have the same input. We should expect to get the same output. Output here is -3. Output here is -2. So they're different. So that means this is not a function. So there's actually multiple places where we have same inputs but different outputs. Again, this produces different outputs for the same input. That's different. So that's a bad thing. It doesn't have to happen more than once. If it happens once, it's not a function. State the domain and range. When we talk about the domain, we're talking about the x values. So we want to list all of the x values. Now these are continuous, so there are an infinite number of x values here. And for the domain here, because this goes on forever, this goes on forever, I'm looking at my x values. My domain in this one is going to be all real numbers. That's how we list every single x value. And my range talks about my y values. And my y values are here. Now it looks like it slows down, but this is going to continue on up here. So every y value, positive and negative, is going to be accounted for. So this is also all real numbers. This one's a little bit different. So my domain, I'm going to do, it is not every. Notice this is not an arrow. The difference between this diagram with the arrows, so let's highlight those arrows. Notice it goes on forever. Goes on forever, where this is finite. Now there are an infinite number of points in between here, but it's very finite. Only x values between -2, -1.5, -1, -0.5, 0, 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4. So I didn't stop here because notice this is an x value. So my domain are values between -2 and 4. How do I do something like that? We say -2 is less than or equal to x, which is less than or equal to 4. So that's what the domain is. I want values between 4 and -2. Notice this statement, x is greater than or equal to -2 and less than or equal to 4. Now, I included them with equal signs because we notice that these are closed circles. So 4 is an x value. When I say my range, now I'm dealing with the y-axis. So now I want to see the tallest y value and the smallest y value. So I go as high as 6 and I go as low as -3. So I would write -3 is less than or equal to y, which is less than or equal to 6. When I talk about the domain, I need to have my x variable. When I talk about the range, I talk about my y variable. And so if we took all of these coordinates, these points, and wrote down every single coordinate, those x values for all those coordinates would be between -2 and 4, including. And if we looked at all those coordinates, my y values would range from -3 to 6. List the intercepts. Intercepts, we're talking about where the line crosses the x-axis. So we have an x-intercept. And we have a y-intercept. So these are talking about the axes. So where does this graph cross the x-axis? Where does it cross the y-axis? So let's look at those points. Let's do the x-intercept. So it crosses the x-axis here, here, and here. So my x-intercepts are -2, 0, and 2. And my y-intercepts, where does it cross the y-axis? Also here. So this is this is both of them. So the y-intercept is 0. So that one's blue and green. We can cut it in half. So they share that intercept. If we look at this one, my x-intercepts, we'll do that, x-axis. So here, 3, that's like 1/3, -1/3, -3. On the assessment, I will definitely do a better job of making it on a grid line. So those are the 3, those are the 4 of them, excuse me. And then my y-intercept. My y-intercept, it crosses the axis at 1. Notice these increments are by 2s. This is by 1. So my y-intercept is actually 1. It's a little tricky there. I don't know if you see that. So that's increments of 2. So that dot is actually at 1. All right. Approximate when the function is positive and negative. So this graph, positive, we're talking about when are our outputs positive and negative, and we define them. You define, that's not define, define with inputs, x's. So when are my outputs? Those are my y's. So when are my y values? When is each of these points above the x-axis? So it starts here and goes along here to infinity. So my x values start at -2 and then increase to positive infinity. So when it's a ray, this is a ray, I use my positive, let's give it, so positive, it is positive when x is greater than -2. I don't do equal to, because at equal, at -2, it's 0. That point is -2, 0. So my output 0 is not positive. So that's why we don't include that. And when is it negative? When is my output, my y value negative, is going to be to the left of -2. So negative, and it's array. So I start with the variable. I want values left of it. So that's less than -2. To the right is greater than, to the left is less than. This one, so again, it's going to start here where it's above the graph, above the x-axis, and it goes to here. So this positive is actually a segment, different from array. When it's a segment, you have a starting point and an end point. You have a low point, -4, and a high point, 2. You put your x in there, and then we use less than signs. And that's how we say x is greater than -4, to the right of -4, but to the left of 2. We want all those values. This, when it's negative, it's array, it's below, and this is array also. So negative, when it's array, we write the variable x first. We write our starting point, -4, and then I want it to the left of it, so that's less than. And this one, x2, and this is to the right, so right is greater than. So that would be your positive and negative for that one. Approximate when the function is increasing, that's a positive slope. This is increasing, this is a positive slope. So increasing. Increasing, this is array, so I start with x. Where does it start? It starts at 3, and I want the values to the right of it. So right is greater than. And where is it decreasing? It's decreasing here. So this section of the graph is decreasing. That's a negative slope. Decreasing. So where is it starting? It's starting here at 3. It's array, so we say x3, and I want the values to the left of it. So left is going to be less than. Okay, so increasing, it's positive slope here, right away to there, and then it's positive slope here. Those are the two positive slope sections. So increasing, those are two rays. So where does it start? It starts at -2. Array, I start with a variable. -2 is where it starts, and I want the values to the left of them. So less than. And then to do this ray, it's a ray, so I start with the variable. Where does it start? At 0, and I want the values to the right of it. To the right is greater than. And then decreasing. Decreasing is going to be this. That's a negative slope. That's a segment. So segment's going to have a starting point, -2, and an ending point, 0. So -2, 0. I put my variable in, and I use less thans. What is the end behavior? So as x goes to positive infinity, as this graph goes to the right, this is AK to the right. So we talk about the right arrow. We want to know what our y's are doing. Are our y's going up or down? Because y can go up or down. So what is this right arrow doing? It's going down, so that would be -infinity. And then the other side would be as x goes to -infinity, aka to the left, what is my y's doing? What are my y values on the left side doing? Well, they're going up. So up is positive infinity. Okay, so that's an end behavior for those. That's it for that one. Do the coordinates represent linear or non-linear? So linear has a constant slope. A constant. That looks like constant. Constant slope. A constant rate of change. So we got to find the rate of change. Rate of change you do by checking out how much is it increasing and decreasing. So between this, that's +4. Between this, that is +2. And then between these two, between my y's, that's plus, what is that? That's +18. +18, and between these two, that's going to be +9. +9. So we're going to take my slope is my y's over my x's. So my y values, these are my y values. Difference of y's was 18 over 4, which simplifies to 18 over 4. That's 9 over 2. And let's take these y's over the x's. So that's 9 over 2. And so the slope between these 2 points is 9/2, and the slope between these 2 points are 9/2. So it is linear. Linear, and you have to tell me why it's linear. Because it has a slope of 9/2. You have to tell me what the slope is. You can't just say it's linear or nonlinear. You have to tell me why. You have to give me a reason. Let's look at this one. So let's do the x's first. So the difference is +2. The difference is +2. We only have to do 2 points. Let's just do 2 points to start. Let's look at this difference is +26. This is plus, ooh, that's a big number. That's 98, +98. So let's find the slope. Slope are the y's over the x's. So my y's is 26 over 2, which simplifies to 13. The slope between these 2 points is 13. Let's do the slope between this. This would be 98 over 2, which is, what's that, 49? Yes? 9 9 is 18. Yep. So it is nonlinear because the slope changes from 13 to 49. And you only need 2 to show that they're different. So this is nonlinear because the slope is changing. It was 13, now it's 49. It'll be something different even here. Evaluate each function. So here's the function. We want to find f of 4. F of 4 is asking for an output. And amongst the output, you can see what your input is. So I'm going to input 4. So f of 4, wherever I see x, equals 4 times, what's my x value? My x value is 4 plus 4. A lot of 4s there. And now we simplify. 4 times 4 is 16 plus 4. So f of 4 equals 20. F of 4, that's my output. This is an output. H of a, so when a is 1, -1, excuse me. So this is important. H, parenthesis, I'm going to substitute my a value, which is -1, close the parenthesis, write the equation, write this negative, and now write what my a value is. Then the plus, then the 3. So h of -1 equals, the opposite of -1 is 1 plus 3. H of -1 equals 4. G of a equals that. We want to know when g of -9. So g of -9, we put a -9 in for a. We get g of -9 equals -18 minus 3. G of -9 equals -21. Graph each function. We see that this is function notation, but it's in slope-intercept form. Slope-intercept form looks like y equals mx plus b, where m is the slope in slope-intercept form, and b is the y-intercept of intercept form. So if we pull it out, the slope is going to be the coefficient of x, and the y-intercept is going to be the constant. So in this case, the slope equals 4, and my y-intercept equals 2. This is the point, so this point is 0, 2. It's a point on the y-axis right here, and my slope is 4. Slope is rise over run, So 4 is a fraction, so we go up 4, and we're going to go right 1 from this y-intercept. We always have to plot the y-intercept. We're going to go up 4, 1, 2, 3, 4, right 1. Now, I can keep going, and I'd run out of space. So if I reverse it, I would go down 4, left 1. So that would get me my third point because we want 3 points here. We're going to connect the dots as best we can. And then there's a couple things that I need from you. I need arrows on that line to show that it goes on forever. And I need you to label these points. That is 1, 6. This is 0, 2. And this point is -1, -2. And let's write so we can see those points. Those coordinates should be next to the point. Don't put them out here. Put them right here next to the point. I need 3 points. I need a line, and I need arrows. Here, my slope is going to be -1, and my y-intercept is going to be -2. So I'm going to do my point first, and this is the only point I'm given. This is not a point. This is a dance. Remember, it's a dance. It's rise over run. So -1, when we talk about up, down, -1 is going to be down 1. And then 1, the rise, run goes right and left. So +1 is right 1. So we're going to go down 1, right 1, down 1, right 1. And then we connect those dots to make a line. We draw arrows. We're going to label our points. That first point is going to be 0, -2. My next point is going to be, that's a bad -2. That looked like a 3. 2. This is going to be 1, -3. And this last point is going to be 2, -4. Those are my points. I've graphed it. That looks good. And that's it. That is just some of the questions. That's a review. Please also understand that you're going to want to do those extra problems. Those extra problems are equally as important in your preparation for your assessment. Good luck.